by having a house where the only irrigation system is grey water puts a lot of responsibility and a sense of pride back onto the homeowner. If they don't maintain their system, their garden will die. And if they're prepared to take on that ownership, and that's only 5 minutes a month plus half an hour per year in maintenance, then the savings are enormous, around about 40,000 gallons per year per family.
Collin talked a little bit about Blackwater. Paul, how widely accepted do you see Blackwater being?
It comes down to the issue of cost. And we just had a discussion about fit for purpose. That if we want to reuse grey water in the house, then it needs to be treated, and that comes at a cost. And that cost varies according to system. Could be 3,500, could be 10,000. So that lends itself very well to commercial applications. Going to Blackwater, sure, it's got the options there, but I'm sure that the cost is quite a bit more than treating grey water. You go back to untreated grey water, and the cost is down to $1,000 for a system and a payback period of 2 years in the US. So it's fitness or suitability for purpose. If you need the water badly enough, you will do Blackwater recycling.
Do you think Blackwater should only be purified by the water purveyor, or could it be done on site?
I really don't have a preference. It comes back to the feasibility study. If it is economically justifiable to do it on site, then it makes sense. We could revert back and say, if I could turn it around to grey water for a minute, Nevada Water Authority was saying it was 8 kilowatt hours per 1,000 gallons in total. If you repump grey water on site, that's actually 0.6 of a kilowatt hour per 1,000 gallons. So it's less than 10% of the energy required than shipping it back to the water purveyor, having them treat it and ship it back out again. So you've really got to balance where are the benefits.
It's like Bill said, water is energy.
Yeah.
One of my favorite quotes was from Gary Klein: every time you turn on a faucet, a pump starts somewhere. Sam, what would you say are the main differences between the Australian and the US market for a manufacturer of water reuse products?
Right. In America, we're involved with water pumps and collection of rainwater. So I'm going to discuss the collection of rainwater. Rainwater in America today is pretty much neglected. Okay, that's a clean resource which is abundant and it's economical. It doesn't cost much to get it. So it's really a resource we should cherish and manage wisely. And this is what we've done in Australia 5 years ago. Okay. What we did, we talked to regulators and explained them the concepts and helped them develop guidelines. We put together testing procedures for our products, and then they wrote the codes along these lines. And since then, it's been a big success. As I said before, now the government is giving incentives for installation of rainwater tanks. And most importantly, people who collect rainwater today are more conscious about the use they make of water. So in the end, they use less water than before they got the rainwater collection system. The case is not desperate in America. It's encouraging. Okay, we've worked with ARCSA, with the IAPMO. We got our product tested here, and we hope to get it on the American market by the end of the year. And some authorities are showing interest. And Albuquerque in New Mexico, for example, I know they managed to reduce the average water use per person from 140 gallons per day down to 80 gallons per day by recommending low-flow sprinklers, etc. If America gets interest in rainwater collection, this can be reduced further down to 40 gallons per day, which we are doing today in Australia. So I'm very optimistic. It's just a matter of getting people together, as Mr. Freeman was saying this morning. We need a collective consciousness, and we'll get the result. Now, rainwater, to give you some figures, the rainwater industry today in Australia, rainwater collection represents $750 million. And the average household can save 40% of water just by reusing what's coming from the sky. And what's coming from the sky, the rainwater pattern is changing, but what's falling from the sky in terms of volume is exactly the same as what was falling at the dinosaurs' time, millions of years ago. It's just not managed.
John, you and I talked a little bit about water reclamation being a good business opportunity for this industry, and we're running a little ahead of schedule, so you can feel free to go through your PowerPoint.
Oh, I had a few slides I want to show then. Can we turn the slides on? Yeah, I just want to say that first of all, the idea of water reuse for the plumbing industry is really a really big idea for us. I think it's, for this trade, it's going to be an emerging industry that's going to represent really billions of dollars of opportunity in the future. This chart actually comes from our friends in Australia. It shows how major commercial buildings, the kind of water use they have. If you look at the three major uses, toilets and urinals, cooling tower, irrigation, those three uses alone, particularly for those first three types of buildings, make up over 90% of the total water use in those buildings. In other words, commercial buildings offer a tremendous opportunity for harvesting water and reusing that water. Oops, sorry. And in an integrated system, there's an opportunity in these buildings to use multiple sources for multiple uses. And so we take a look at not just the rooftop rainwater, but the stormwater, gray water, cooling condensate, and other sources, and then think about how that can be applied. And the most common use is landscape irrigation, but obviously toilet flushing is a big opportunity for us, cooling tower makeup, and others have been mentioned here today. So it really becomes a matter of how do we best match the overall sources of water that could be harvested and reused with those non-potable uses, and we try to find a system that can take multiple sources and then clean it up in the appropriate way to apply it multiple uses overall. And the trick really for our industry is to get involved early in the process, that in order to have a really efficient system working, you've got to get at the very beginning of a building design. That means the very concept of the building, working with the architects to help scope a system to try to figure out what the best combination of sources and uses would be, how we're going to store that water, how we're going to clean it, etc., moving to the engineering of that building to make sure the building is accommodating for that system, so it's built into the system. And then when the plumbing trade comes in, usually at the fabrication installation stage, where the plumbers really are partners in this whole process for running all the plumbing lines, for helping to install these systems, to commission them, get them up and running, and also the ongoing service and maintenance of the systems. So really, the best systems are designed early on and go all the way through the whole building process. And then as far as the building, the system design itself, the primary storage and filtration, sanitation, stabilization, the final filtration, pressurization, those are really, we custom adjust those building by building. There is not one system that will fit for every building, or even multiple systems that fit. So we find the most efficient systems are those where the components have been designed to work with the building and its unique needs and uses. So typical system, primary filtration storage, underground storage is very common. We can do above ground storage as well. There's some kind of sanitation stage or stabilization stage, and we talked before about reusing gray water. In a commercial building, it's always going to be processed. We're going to transition that water from being gray water into being on-site treated water. So the whole standard of how we think about that water and its use switches, because it's no longer gray water. Now it is water that's been treated for on-site reuse. And then final filtration and pressurization.